Welcome back, class, and today we're going to finish up chapter 4, and we're going to do it with section 4, and it's going to be on non-standard problems. And so non-standard problems are going to be a little bit more complicated, but you can do it as long as you just take your time and practice these. There's an added, how do I say this? An added twist at the beginning that you have to do with non-standard problems. And then once you get through this part of it, then it becomes a regular simplex problem. Okay, and non-standard problems are non-standard because in the standard problems that we've looked at, they've had certain conditions, right, that I pointed out. One, all of the inequalities go in the same direction. Okay, so in the maximization problems, all of the inequalities are greater than, or no, less than, sorry. All of the inequalities are less than. For a minimization problem, all of the inequalities then are greater than. Okay, so in a non-standard problem, they're mixed. Okay, so you will have constraints that are that have both. Okay, some constraints will be less than or equal to, other constraints will be greater than or equal to. Okay, and so when we have those, we've got to consider more. Okay, you can't just work them out the standard way. The standard method does not work with those. Okay, so let's go on. So here is the process. Okay, so I'm going to explain this in words, and then I'm going to walk through an example. Okay, so if we have a non-standard problem, then we're going to treat it in a lot of ways similar, but in a lot of ways very different than what we've done. So first of all, number 1 says, if necessary, convert the problem to a maximization problem. So this means that if it's a minimization type problem, then the objective function is going to be written as W, or you are going to write it as W if the word problem is a minimization problem that is non-standard. Okay, so we're going to write it as a maximization problem using the duality. Or excuse me, not using duality. We don't use duality. Sorry, scratch it. I don't know what I'm talking about. In a non-standard problem, you're not going to transpose the matrix. You're not going to do anything like that if they're asking you to minimize a problem. But the way you transform it into a maximization problem is by taking the opposite of W. Okay, you're going to keep the constraints as they are. You're not going to change the constraints at all. And you're just going to say, you're going to define Z as the opposite of W. Okay, that's what you're going to do. Then number 2 says, add the slack variables and subtract surplus variables as needed. Now, surplus variables I'm going to explain, but surplus variables are added, or excuse me, subtracted when you have constraints that are in the form of greater than or equal to. Okay, because in order to change it to an equal sign, when you change it to an equal sign, well, that means you're going to have to subtract any surplus in order to make it into an equal. Okay, so now once you do that, then you're going to write your initial simplex tableau. Now, steps 4 through 7 are where it's different than what we've been doing. Okay, 4, we're going to look at the basic variable. Okay, we're going to look at the basic variables. And if any basic variable has a negative value, okay, there may be more than one. Doesn't matter which one you choose. Typically, what you'll see in the textbook is they'll choose the leftmost column, the leftmost um, basic column that has a negative in it. Okay, so if we choose that column that has a negative in it, okay, then the row that negative value is in is going to be our row we're going to concentrate on. Okay, it's going to be our, it's not going to be the pivot row. Okay, so this is where it's a little different. Okay, so once we find the non-variable column, okay, farthest to the left that has a negative value in it, that's going to, whatever row that negative value is in, is the row we want to focus on. Okay, then we're going to go to step 5 and says, okay, in that row that we indicated in step 4, we're going to go all the way to the left of that row, and we're going to find the number that's positive, the leftmost positive number in that row, and that's going to indicate the column that our pivot is going to be in. Okay, now the way we choose our pivot is by investigating the quotients, just like before, but the quotients are used differently this time. The quotients are going to help us indicate which number, which entry in the corresponding column is going to be our pivot. Okay, and of course, the one that gives us the smallest quotient is going to be our pivot. Okay, then in step 7, we're going to use our elementary row operations to change the other numbers in that pivot column to 0. Okay, and then what we're going to do is once we're done with that, then what we're going to do is we're going to again look at the basic variables. Okay, identify the basic variables again, and then choose the one, if there are any, choose one that's negative. Okay, and then we'll do this process all over again until there are no more basic variables that are negative. Okay, now if it ever becomes impossible to continue, which means let's say we can't get the quotients, all the quotients get discarded because we're dividing either by 0 or a negative number. If that happens, we're done. There are no feasible solutions if that occurs. If we're not able to get rid of all of the negative basic variables, then there are no solutions. Okay, now, once there is a feasible solution, okay, step 9, once there is a feasible solution that has been found, which means that we've eliminated all the negative basic variables, now we're ready to use the simplex method until an optimal solution is found. Okay, so then once we get to step 9, we're right back to where the same old stuff we've been doing in the previous sections. Okay, now before I end, I want to do some examples. So let's escape out of here and let's go to no, I can't believe I closed that out. I didn't mean to close that out. Okay, so I'll have to go in and open it again. So bear with me. I wanted to do an example. Let's see here. Sorry about this. I had it up and I must have accidentally closed it. Okay, here we go. Okay, so I just got to pull up the e-text here once I get into the class. Okay, so once I get in here and I show you one of the examples, I'm going to walk through the examples, but please make sure you do these examples on your own. Do the your turns as well. Those are invaluable ways of just practicing with something you don't have the solution to, and then just use the other examples to help you with the process. So I'm going to go work through one of the examples um, and show you what they're doing. Now, I don't believe they work out the entire example. They work it out until you get to a point where you can use the simplex method and you're off to the races. Okay, why is this taking so long? Oh, here we go. I think it might be because I have a video rendering in the background. Might be the reason why it's taking so long. Come on now. Okay, so let's go to 5 non-standard problems, and here we go. Anytime. Okay. Ah, okay. So let's go back. Okay, so in the potatoes, so is this the one we want to use? Let's do a different one because this one doesn't have. So that's the previous one we did, but I want a different one. Okay, so notice this one here. So this one's a minimization problem. Okay, so the first thing we're going to do is we're going to change this to z. We're going to define, because it's a minimization problem, we want to change it to a maximization problem. So the first thing we're going to do is we're going to define z. Oops. We're going to define z as negative w. So in other words, we're going to change the signs of w and we're going to name that z. So now our maximization problem becomes z is equal to this. And now notice that we didn't change the variables and we kept the constraints the way they are. Okay, so different than what we did in the previous section. So we're going to use this. Now what we're going to do is we're going to set up our initial tableau with all of our slack variables and our surplus variables. So notice these are the constraints. So for this one here, we're going to add a slack variable. Okay. For this one here, we're going to subtract off a surplus variable. And so when we set up our tableau, we're going to have our y1s, y2, and then s1 and then minus S2, and then Z. Okay, so now, and again, now we have a system of equations where we have 1, 2, 3, 4, 5, or 4 unknowns. Okay, 4 unknowns and 3 equations. Okay, so that means we're going to have our basic variables. Okay, so what are the basic variables? Well, it's going to be S1 and S2. Okay, those are the basic variables. And so now notice that we have a negative basic variable here. So this is the row we're going to want to be in. And then we take the leftmost positive value here, and this is the column that we're going to be in. And then we're going to take these constants here, we're going to divide by these coefficients, and the one that gives us the smallest value, which is going to be this one, 3/2. 3/2 is definitely less than 6. And so 2 is going to be our pivot. Okay, so again, remember, we're going to find the basic variable that has a negative entry. That is going to determine the row we want to be in. And then we go to the leftmost positive number, and that's going to determine the column that we need to be in. And then we're going to use the quotients to help us find the pivot, which is going to be the smallest quotient. The smallest quotient is going to tell us the entry that is going to be our pivot. Okay, so it's like the opposite direction that we went before. Okay, so now 2 is our pivot. So now what we're going to do is our elementary row operations to make 3, 0 and 1, 0, and of course row 1 and row 3 are going to change then. And so now what happens is when we do that, our 2 elementary row operations, these become zeros, and now these change, and now we look at our basic variables again. Now look, now y1 and s1 are our basic variables. Notice that s2 is now a non-variable. When we use the pivot, we changed y1 from a non-basic variable to a basic variable, and s1 went from a basic variable to a non-basic variable. That's why we go through the process of choosing our row and our column and our pivot. It's to make S2 go from basic to non-basic. Okay, so now we look at these 2 basic variables, and there are no negative values. So therefore, we are ready to start the simplex method. Okay, now to use the simplex method, again, look at this. We look for a negative indicator. Well, guess what? Here we don't have a negative indicator. So there are no negative indicators. So guess what? We're done because this is maximized. Now the only thing we have to do is we have to look at our basic variables. Now the basic variables we divide by 2. Okay, so we're going to divide this by 2 because we want this to be a 1. We're going to divide this by 2 because we want this to be a 1. And we're going to divide this by 2 because we need z to be a 1. So this means we're going to have 9/2, 3/2, and negative 9/2. And this is going to be 3/2 and 1. So we're going to get 1/2, 3/2, 1. Okay, and then negative 9/2. So guess what? Now, what we just found is z, right? Z is equal to negative 9/2, which means w is going to be positive 9/2. Okay, so keep that in mind. So w is 9/2. Okay, now how do we look at this? Well, in this case here, what do we get? Well, we divided these by 2. In fact, we divided everything by 2. Okay, so our final solution is when y1 is 3/2, because where's y1? y1 is right here. Okay, when y1 is 3/2 and y2 is 0. Okay, where's y2? Well, y2 is here, but y2 is a non-basic variable, so y2 is 0. So that means when y1 is 3/2 and y2 is 0, then w is going to have a minimum value of 9/2. Okay. So again, the main thing that's different is eliminating the negatives, or making sure that all of the basic variables have no negative values in there. Once we've transformed the tableau by using the steps that we just went through to eliminate the negative entries, or not eliminating the negative entries, but making sure that we get to a tableau that has basic variables that have no negative entries, then we can start our simplex method the same way. And then once we get our tableau to our final tableau, which has no negative indicators, then we can go ahead and redefine, we can find out what W is. Okay. So again, practice these, do your turns, do this one on your own, try to work out this problem on your own, make sure you understand it. Do again, practice the problems at the end of the chapter. Okay, so here's one example here. Here's another one. So now in this one here, we're going to use artificial variables. So this is another special case. Now again, this one, and this is the last topic we'll cover, is what happens if we have equals? What if we have equations as part of our list of constraints? Well, this is where we're going to use artificial variables, or what I call dummy variables, placeholders. Okay, so what we're going to do is, if there's an equal sign, okay, we're going to add these arbitrary variables. Okay, and so what happens is, again, all the variables are non-negative. We've got this set of W, right? And again, we're minimizing the cost of transporting the cars. Okay, so but let's say we want this to be equal, right? Before we had them, it was greater than. But what if we just want it to be equal to? Okay, so we get 20 and 16. Okay, now that's more realistic. Okay, because usually dealerships, they say we need this many cars, and they don't just send, well, we'll send you 20 if you really, okay, you need 16, but we'll send you 20. Okay, usually it doesn't happen that way. Usually the dealerships say, hey, we need this many cars, and then they fulfill the order, right? The manufacturer fulfills the order. Okay, so this is going to be more realistic. Now, how do we handle this? Well, we're going to add, for each one of these equations, we're going to add an artificial variable, and we use those A's for artificial, right? So A1 and A sub 1 and A sub 2. Okay, and they're going to require special handling, and we're going to show you how to do that. Because what we're going to do is we're going to look at these first. Okay, so if you, again, set it up the way you normally set it up, okay, here are your constraints, here's your Z, right? Again, we're setting it up as negative W, so again, everything's the same, and we have these two artificial variables. Okay, we got our slack variables and we got our artificial variables. Okay, so what we're going to do is we're going to do we're going to use the same tableau. So again, we set up the same tableau as an example, to accept that the columns labeled S3 and S4 are now A1 and A2. Okay, notice that they start over. Okay, so artificial variables start over with their own numbering. Okay, and also there is an initial 1 rather than a negative 1. Okay, for A1 and A2. So different than what we did with the surplus variables. Okay, now the first 3 pivots are the same as in example 2. Okay, meaning okay, we're going to result in this tableau. So what does that mean? Well, if we go to example 2, just to back up, oops. So here's our initial tableau. So notice that in this case, we did the first transformations with these two. Okay, so notice that in this case here, oh, just to show you, well, this is the only negative one, so never mind. So I was thinking, so here's the S4, and they use the simplex, or not the simplex, but they use the method to find the pivot that we did just a moment ago with the other example. So in this case here, in this artificial variable, what we're going to do is the first goal of the simplex method is to eliminate any artificial variables as basic variables. The same thing that we did with the surplus variables. Okay. So since they must have a value of 0 in the solution, okay, so we don't want them to have, so that's why they have to be non-basic. So we're going to do this the same way that we changed the surplus variables from having negative values to being 0. We're going to change them from basic to non-basic. Now the only difference is that once an artificial variable is made non-basic, we must never pivot on that column again. Okay, again, we must never pivot on that column again because that would change it back to a basic variable. Okay, so we want to avoid that. Okay, we must never carry out any pivot that would result in an artificial variable becoming non-zero. Okay, so now if we look at this here, we're going to do the same thing. So what we're going to do is we've got these, and again, it doesn't matter which one you start with. So we've got these basic variables here. In fact, this one right here, or excuse me. So these are the basic variables, and so we want to eliminate these two first. Okay, so we start with whichever one, it doesn't matter. Okay, so this is our tableau, and we go through the same steps that we just did with the surplus variables. So we want to eliminate these. So, and again, it doesn't matter which one you start with. Okay, so we could start with this one. And so if we start with this one, oh, hold on a second here. I didn't go. So if we start with this one, we're going to do the same two steps, or excuse me, start with this. We're going to do the same two steps that we did in example 2, and we're going to eliminate these of being basic variables. So if you notice, we get the same tableau that we got before. So notice that these are no longer basic. And now our basic variables is this one, this one, this one, and S2. So we get the first 3 variables, and S2 are now basic. Okay, so now we can go ahead and start working with the simplex method, because now we're down to just these slack variables. But remember, we don't want to pivot on either of these variables again. Okay, so remember, never pivot on that column again. Okay, so we'll just have to be careful of that. Okay, so now if we look at this here, we've got negative indicators. So guess what? Now we're basically going to do the same process that we did before. Okay, so now ordinarily our next step would be to pivot on the column that has a negative 480, but that is not allowed because it would make A2 a basic variable. So let's go back. See, now if we pivot on here, right, the most negative, well, we're back to A1. So we got to avoid this one. We've also got to avoid this one. So guess what? We're going to have to pivot on this one. Okay? And I believe that's what they do. Similarly, we cannot pivot on the column of -4. So what we're going to have to do is we go to the -300, exactly what I said. Okay. Now, verify that after this step and one more tableau, okay, we reach the same solution as we did in example 2. Okay. Now, in other problems, now that's not always going to happen. In other problems, the quality constraints can result in higher cost. Okay. Okay. Again, work through this one on your own. Make sure you follow the steps, watch this video, read the textbook, ask questions in class, practice, practice, practice. You know what to do. Until then, I'll see you in class, and have fun and take care. Bye-bye.